First, let's add a background to our game. Drag the Set Background Image to Block from the Scene section and place it at the beginning of the OnStart event. Click on the square icon within this block to open the image editor. Here, you have the option to use a stock image or create your own. For this tutorial, I'll use the built-in cityscape image. After the simulator reloads the game, you'll see that the background image is set, and our car sprite appears on the screen. As the number of blocks inside the OnStart event increases, it becomes essential to organize them for better readability and management. Let's do this by creating functions. We'll start by making a createCars function. In this function, we'll include the code for creating the 6 car sprites. After defining this function, go to the Function section and drag a call createCars block into the OnStart event. Let's rearrange the events or functions in the pane for better organization. Now, we're set to add the planes. Create a new function named createPlanes. Similar to how we added the car sprite, start by dragging in the Set MySprite to block. Click on the sprite image icon to choose a suitable image. For this example, I'm using the built-in red plane image. Next, use the Set MySprite Position block to place the sprite at a specific location on the screen. Here, we should modify the coordinates to position the sprite where we want it. It's also a good idea to change the sprite's kind from player to enemy. And remember to drag the call createPlane block to the OnStart event. It seems the position is fine by now. Following the approach we used with the cars, create an array named listPlanes to store the plane instances. We'll also use a list to keep track of the x-coordinates of the planes. Utilize a for loop to generate these 6 planes based on this list. You can modify the numbers in the list to adjust the positions of the planes. Additionally, within the loop, consider implementing some kind of offset mechanism. Adjust this offset until the plane sprites are positioned as desired. Next, we will add bomb sprites to the game. First, we create a function named createBombs. Drag the Set MySprite to block into it. Then, create or choose the sprite image. In this example, we are using a stock image and flipping it horizontally. Now, use the Set Sprite Position block to specify the coordinates of this bomb. Also, drag the call createBombs to the OnStart event. This bomb will serve as the anchor for the other bombs. So, try to position it in the appropriate place. Okay, seems alright now, so let's make the single bomb into a column of bombs. As we always do, create an array to store this column of bombs. Copy the setArray block and the looping block from the previously defined createPlane function. Create a new variable for this list and name it listBombCall, where call signifies column. In the loop, add the sprite to the listBomb column. Also, copy the coordinate list from the createPlane function for consistency. Up to this point, the code for createBombs has been quite similar to that of createPlane. However, a key distinction emerges as we now aim to create a grid of bombs. This grid will consist of 4 columns, with each column containing 5 rows of bombs. Effectively, we'll create 4 columns of bombs, collectively forming a bomb set. To achieve this, we will employ 2 nested loops. The outer loop, referred to as loop 1, will iterate across each of these 4 columns. The inner loop, referred to as loop 2, will iterate through the bombs within each specific column. Here we have already configured 2 loops along with their respective coordinate lists. In MakeCode, the for-element value of list loop typically uses value as the looping variable. However, in our case of creating a bomb grid, we need 2 distinct looping variables to manage the nested loops effectively. Therefore, we manually define 2 variables, value x and value y. These variables will serve as our looping variables. Here, value x will correspond to the x-coordinate, and value y will correspond to the y-coordinate of each bomb in the grid. Now, we will nest the y-axis loop within the x-axis loop. Importantly, since the values in list y remain constant during each iteration of the loop, we can optimize our code by moving the setListYItems value outside of the loop and placing it at the beginning of the createBombSet function for efficiency. Now, let's break down the steps within these nested loops. First, generate an empty array for each column. Then create a bomb sprite, and add the bomb sprite to the column array. Once a column of bomb sprites is created, we need to integrate this column into the overall bomb set. This action marks the end of the outer loop. Now we can use the variables value x and value y to determine the precise location of each bomb sprite. We'll add an offset to these values to position the sprites correctly. Furthermore, since we require only 4 columns of bombs, we shall remove 2 items from list X. This ensures that our bomb set consists of the correct number of columns. Next, let's fine-tune the offset to ensure that our grid of bombs is positioned correctly on the screen. Okay, looks good enough. To facilitate the easy updating of bomb sprites visibility, we will add the sprite at the list's beginning instead of at the end of the list. So here we change the list add value to end block to the list insert value at beginning block. Also, we shall classify the bombs as projectiles. Now we have 3 kinds of sprites: player, enemy, and projectile. Update the setAllSpritesVisible function. Use 2 loops to update both enemy and projectile sprites, just as we did on the player kind of sprites. Test with our A/B buttons. Okay, cool, they work perfectly. Let's animate our plane flying through the sky. We want it to change its location every 200 milliseconds. To do this, modify the onGameUpdate every 500 milliseconds block by changing the time to 200 milliseconds. For the plane's position, we'll use a variable named planeLocation, similar to how we used playerLocation for the player. Initially, set planeLocation to 0. This can be done in the createPlanes function. But for better organization, let's place this initialization in the onStart event, alongside where we set playerLocation to 0. We'll be utilizing the variable planeLocation to simulate the movement of a bomber plane flying across the sky at an interval of several seconds. As illustrated in the chart, the plane starts its journey from the right side at a far distance before entering the visible area of the screen. This design creates a simulated interval between the consecutive two fly-throughs. Each time the game updates, if the plane is in this off-screen area, we won't be able to see the plane. In this scenario, we simply adjust the plane's location by decrementing it by 1. When the plane is within the visible area of the screen, we need to do more than just change its location. We need to show and hide the corresponding sprite to create a convincing animation of the plane flying. Once the plane exits the screen's left boundary, we need to reposition it to the far right side. This allows the plane to re-enter and fly across the screen again later on. As we have discussed, let's begin by dragging the if-else block into the onGameUpdate block. The default action is to change the plane's location by -1. The first condition we'll set is to check if the plane's location is greater than the length of the list plane. The next condition to set is when the plane's location equals the length of the list plane. In this scenario, we'll start showing the rightmost plane sprite. Duplicate the Set Sprite Invisible block, change the list reference to list plane, and set the index to the plane's location. For the scenario where the plane's location is within the visible screen, our condition will be plane location greater than 0. In this case, we need to make the sprite at the previous location of the plane invisible, change the plane's location by -1, and then set the sprite at the plane's new location to visible. The final case to handle is when the plane has flown past the left edge of the screen. The condition here would be plane location less than 0. However, we don't need to explicitly check for this condition, as it is the only remaining possibility. In this scenario, we should reset the plane's location to the far right of the screen. For this, use the Pick Random block from the Math section and set it to choose a random number between 30 and 60. That's about 6 to 12 seconds. We will utilize this block to substitute the Set Plane Location to 0 block in the onStart event. Now, let's test our code using the simulator. Oops, we forgot to set the last plane sprite invisible when the plane passes through the left boundary of the screen. Duplicate one from the above case and set it here. Let's run another test in the simulator. Great, it's functioning as expected now. In the next part, we will start working on the falling bombs.